Hi everyone, how are you? Welcome to today's recall session. Actually, it is the explanation of the recalls. Our today's topics, January 2023. So let's see the first question of January 2023, half-life of the platelet. So it is direct question that we have to know about the half-life of the platelet. Here are the options. Options are 12 hours, 2 days, 10 days, 20 days, 30 days. So as it is direct question, so we have to memorize the half-life of the platelet and other blood cells. So let's see. Here we can see the platelet. The platelet, it is circulate with an average lifespan of 7 to 10 days. So the half-life of platelet, it is 7 to 10 days. So it is quite enough. Approximately one third of the platelet reside in the spleen. That means they are stored in the spleen, and this number increase in proportion to liver size. Although the platelet count rarely decrease less than 40,000 as the spleen enlarge. Now the lifespan of the WBC, we know the WBC, they are divided into 5 groups: neutrophil, eosinophil, basophil, monocyte and lymphocyte. Here we can see lymphocyte, which is 2 to 5 days, and lymphocyte, which is half to 1 days, and the monocyte, it is the 2 to 5 days. So the shortest half life of the WBC, here the lymphocyte, which is half to 1 day, and 2 to 5 day neutrophil and monocyte. But eosinophil and basophil, they are relatively longer half life, such as the eosinophil, it has 7 to 12 days, and basophil 12 to 15 days. So it is now ready that the half-life of platelet, it is 10 days. It is 7 to 10 days, and it is well known to us that the half-life of RBC, it is 120 days. So among the all blood cell, only the RBC, the longest half-life, which is the 120 days. 120 days. Now the second question, a bullet is shot just at the right side of the rectus muscle where it meets the tight costal margin and went out the exact area through the back. Organ most likely affected. So first of all, we have to find out the location. Here we can see it is the right side, and right sides of the rectus muscle. We know the rectus muscle, they lies in the midline where it meets the tight costal margin and went out the exact area through the back. Organ mostly likely affected. Here the options are pylorus, liver, gallbladder, kidney and duodenum. So we have to find out on of the organ or of the viscera which may be damaged during this bullet shot, and the exact location at the junction of the rectus muscle and costal margin. So now see some of the questions. So here we can see this is the rectus muscle. Here this is one rectus muscle, another, this is another rectus muscle, and right side the costal margin. Here we can see this is the costal margin, here this is the costal margin, and we can see structure. This structure, it is located at the junction of the costal margin and the rectus sheath, and this structure we know it is the gallbladder. And here another picture, this is the costal margin right sided, and this structure usually located this area, it is the gallbladder. So at the junction of the rectus sheath on the right side and the costal margin, it is the gallbladder. See the picture again, where we can see this is the gallbladder. Now the third question, which is the Paneth cell present in Paneth cell, which is one of the cell in the gastrointestinal tract. We have to find out the location of the Paneth cell. Here the options are crypt of livercule, intestinal villi, gastric antrum, lamina propria and muscle layer. Paneth cell, usually the most active cell, they are present in the mucosa. So the lamina propria and muscle layer, they are the wrong option. So we have to find out gastric antrum, intestinal pillar or crypts of livercule. So we have to find out the Paneth cell in the gastrointestinal tract, in the epithelial surface, not in the lamina propria, not in the muscle layer. So here we can see this is the Paneth cell. So this cell, this they are the Paneth cell, and this is the luminal surface. Here we can see this is the luminal surface, and this luminal surface is covered by the mucus to protect these gastrointestinal luminal surface from different type of the injury. And here we can see this cell, the enterocyte, and other cells such as here we can see the enteroendocrine cell. This is the stem cell, and here we can see the blood cell, which is the T cell, dendritic cell, macrophage, which is immunologically active. They are the lamina propria. And here we can see the Paneth cell. It is located in this. Here we can see this is the depression, which is known as the crypt of Leverkusen. So the Paneth cell is located in the crypt of gastrointestinal system, which is the crypt known as the crypt of Leverkusen. So here we can see the crypt base contains Paneth cell. That means the crypt of Leverkusen, it contains the Paneth cell. And in this picture also, here we can see this is the intestinal crypt or crypt of Leverkusen, and at the base of the crypt it is here the Paneth cell located. So it is now clear that the Paneth cell is present in the crypt of Leverkusen. Now option 4, which is in COPD patients, what will happen? Here the options are partial pressure of carbon dioxide increase and bicarbonate also increase, partial pressure of carbon dioxide increase and bicarbonate decrease, partial pressure of carbon dioxide decrease and bicarbonate increase, partial pressure of carbon dioxide decrease and bicarbonate decrease, partial pressure of carbon dioxide no sense and bicarbonate increase. So we have to find out one of the option in which occurs in COPD patient. So we know that in COPD patient, what happens in this patient, in COPD patient, usually the partial pressure of carbon dioxide increase. That means in COPD patient there is the acidosis develop, and this acidosis is a respiratory acidosis because it occurs due to lung cause. So any cause responsible for or any metabolic abnormality developed from the lung cause, it is called a respiratory. And in case of COPD patient, it occurs due to carbon dioxide retention and due to carbon dioxide acidic. So in COPD patient, carbon dioxide increases. But we have to see the other option, which is the bicarbonate. So what is the fate of the bicarbonate? So let's see. So first of all, we can see the pH is related to just forget this area. Imagine they are not located. So pH is equal to salt, which is bicarbonate. So here salt is the bicarbonate and acid is the partial pressure of carbon dioxide. So in case of COPD patient, what happens? The partial pressure of carbon dioxide increase. That means the pH decrease. So in case of COPD patient, as the partial pressure of bicarbonate it is increased, so the pH will decrease. So what is the fate of the bicarbonate now? So our body has a strong defense system. The body wants to keep the pH within the normal limit. So balance of this pH, that means to uh, get back of the pH level, the bicarbonate, it will also increase. So what will happen? Initially, partial pressure of carbon dioxide will increase, and for the compensation, bicarbonate level also have to increase for the balance of the pH level. So this is our option: partial pressure of carbon dioxide increase and also partial pressure of bicarbonate increase. Another option, COPD patient given morphine, which ABG represented. Here the options are partially compensated respiratory alkalosis, partially compensated metabolic acidosis, partially compensated metabolic alkalosis, no sense, and partially compensated respiratory acidosis. So again, the same portion which is in COPD patient. So in COPD patient, carbon dioxide retention occurs. That means they not possible for carbon dioxide to wash out properly. For this acidosis develop, and Here we can see, and which type of acidosis this is the respiratory acidosis. So first of all, let's see the respiratory acidosis. Here we can see in option only one present, respiratory acidosis, which is the number E, which is partially compensated respiratory acidosis. So again, see the PA is, first of all, salt is the bicarbonate level, and acid is the partial pressure of carbon dioxide level. And in COPD patient, carbon dioxide reduce, so PA is also reduced, and then the salt, which is bicarbonate level, it has also to reduce. And this patient given morphine, so it is the partially compensated respiratory acidosis. Thank you all.